All right, welcome everybody. Today we're going to talk about solubility and we're going to use the reaction of potassium nitrate and iron iodide, or lead iodide, excuse me, to discuss solubility rules and then figure out how temperature affects solubility. So let's actually go into the reaction here. First, we see that we have lead nitrate, which is a aqueous solution, which means that the lead nitrate is soluble in water to a certain extent, as well as potassium iodide. And when we mix those two solutions together, we should expect to form a solid precipitate within the lead iodide, plus have two ions, one negative and one positive ion floating in solution in the water as we mix it and form our products. Once we develop that products, or these set of products, we can then play around with that solution, actually heat it up to redissolve the lead iodide in the solution. Again, when we talk about solubility rules, at room temperature, lead iodide does not follow proper solubility rules, therefore it should precipitate out. But with enough energy, the molecules actually have just the right amount of collisions to push that over the activation energy barrier and form the products and dissolve in the solution. So we're going to see that, and then we can then again play around with that concept, take it out of the dissolved solution, and see what happens with the lead iodide after the solution cools down. We would expect it to then again precipitate out again. So we're going to show you and help you observe what happens when we understand solubility rules and how it plays into these reactions. Okay, so I have my lead nitrate here as well as my potassium iodide. I'm going to use a pipette and start to add just a couple of drops into the potassium iodide. Start to see the formation of a yellow compound in there. That's the potassium or the lead iodide now in the product form. And again, as of right now, we don't have many of it, so you can see it's still hanging around in solution, but as you start to add more, you can see that it's starting to, slowly crystallize in the solution. Once you add enough drops there, you can actually dump the remaining solution and mix them together, and you start to see a nice slushy and a slur of compound inside of the solution. So you can see that nice golden compound there. For the fun of it. All right. So that now that we have that, what we're going to do next is heat this up to show you how it redissolves in the solution based on temperature. All right, slide it over here. Don't touch the hot surface, that's a bad idea. All right, so we've put our beaker into solution. We've had it heated up for several minutes now, and when we take it out, it's definitely a little hot. So, my hands are made of insulated material, so they don't ever get hot. Yours may not be, so make sure you use proper protection. But what you can see here, that the solution is actually clear here. There's a little bit of precipitate at the bottom. You may see that, but for the most part, it's redissolved into the solution. Now, if we were to let it to sit here over time, and you'll just get to observe that, we'll watch it start to precipitate back out, what we like to call golden rain. And again, hopefully this explains to you the concept of solubility rules and precipitation and how that all comes into fact when, I don't know, I'm rambling now. I'm just going to let this run here. Hopefully you're just looking at that and not my hands. So you just do that and then All right, so now that we've let it settle out for a little bit and you see the time-lapse version of it, hopefully you can see the nice recrystallization happen, with the precipitate of the lead iodide, settle out of the solution as we let the temperature cool down. All right, so what you'll see here now is the recrystallization of the lead iodide now that the temperature of the solution has cooled down and the lead iodide has precipitated out. So you can see the difference here between what happened at room temperature and the solubility of the formation of the products at room temperature, as well as the recrystallization of the products after it was dissolved in solution. So again, this shows you key stark differences in how crystallization happens in solutions and how that can be affected by solubility and temperatures related to the reaction. So hopefully this gives you a good idea about solubility and how solubility is affected with temperature. Look forward to you engaging with us in the next videos. Thank you.